Thank you for the introduction to my presentation on the topic ultrasound sensors for process and fouling monitoring in emulsion polymerization process. My name is Marco Osenberg and I'm doing research in the field of fouling measurement for the Ruhr-Universität Bochum. I would give you a short overview of my presentation. At the beginning, I will explain the motivation of the fouling detection and describe the used emulsion polymerization process. Then I will present the measurement setup with the measuring cell and the signal evaluation. And at the end of this presentation, I will give you a short summary and conclusion. The chemical industry consumes large amounts of energy and resources. To ensure good energy and resource efficiency, it is necessary to improve the process currently in operation. There are many ways to optimize these processes. One way is to change the batch process to continuous processes. Primarily, studies on this chemical system have shown that the biggest problem in this production operation, the forming of fouling is. This in turn leads to increased cost, energy, and resource consumptions. For this, the German government have founded this research project I worked on. On the picture on the left, I would like to show you an example of the result fouling. I think you can imagine that this fouling can create a lot of problems. In a course, in all components of the equipment, especially in mixers and heat exchangers, this fouling decrease. This create increased energy consumes due to the terminal ensure and pressure losses in the structures. The debug time and mixing quality will negatively affect on the quality of the product. Cleaning processes exist. The clean, they exist and they can clean the components, but it's very expensive. However, they are very time consuming and expensive, so they should be used as seldom as possible. But if it clean to start too late, it comes much more expensive. Therefore, it's very important to measure this contamination status in the process in order to optimally adapt the cleaning process to the plant conditions. The chemical process is one of the most important technical processes to produce a bulk polymer. In this process, a hydrophobic monomer mixed in a fluid phase with the aid of an emulsifier. We see it here on the left side. They are the monomer and the emulsifier, and they mix it. By adding this initiator, the reaction starts. And this reaction worked on a temperature-controlled reactor here in the back. A measuring cell to detect the fouling is currently after the reactor. The fouling in the measuring cell is similar to the fouling we found in the mixers and in the tubes. The main obstacle is the solid content up to 23% after the reaction. This leads to very strong scattering results in the low signal-to-noise ratio, especially when the high acoustic frequency used. The chemical system we used has a sound velocity from 1,410 meters per second by a temperature from 20 degrees. As already explained, we need to measurement cell that we measure the fouling in a closed system, which I would now like to present. So to ensure that the measuring cell is resistant to the chemicals we use, the most components were made of stainless steel without the coupling pads here in the top. This made of PEEK that allowed us to couple more energy into the cell and into the system. In addition to the ultrasound transducer we use, the center frequency of 5 megahertz were chosen. And we take a temperature measurement in the bottom of this view here in the back wall. To keep the temperature with minimum fluctuations, a temperature control circles are installed in this measuring cell and fluid here around the middle path. The formation of fouling in this measuring cell is promoted by a flow-reduced zone. This is here in this area the most time, or here in the back well end here. And that's we need these flow-reduced zones that the fouling have time to grow up in this measurement cell. For the evaluation of this measurement signal, 3 different parameters are analyzed to determine the fouling thickness. The average sound velocity in the mesh cell, we take here the time difference between coupling the ultrasound signals to the chemical stream and the background. This sound velocity is important to depends the solid content. So we can see the process of the system and the reaction, and can check on which time on the reaction we are. From minute 4, we have here one example plotted from minute 4. The initiator is added, which starts a reaction. From the change in the sound velocity, it can be observed as soon as the system is in constant solid conditions. So we are in a solid condition here at minute 16. And we see here that the solid condition already reached, so we changed the sound velocity in the middle of the measuring itself. The second parameter evaluated is the coupling reflection when coupled into the measuring cell. Due to the coupling reflection, the accumulation of contamination on the peak surface can be observed, also this time here in the coupling path. The higher the reflection power, the more energy is consumed in the sensing element, conferring an increasing in acoustic impedance on this peak. From minute 25, we consider we have a constant level, that reflection from the reflection signal, and this shows that the layer is contaminated on the complete section where we measure. Finally, the attenuation in the measuring cell is evaluated for the purpose. The amplitude of the background reflection here on the background we use to consider the attenuation. With the start of the reaction, a constant drop of the we detect here, and this is why we have an effect from rising the solid condition, and of course to get the fouling in the cell. So we have a continually drop of the attenuation. The first time till the system is stable is from the changing of the solid state, and after that we can see that the fouling are growing. Only by links, the 3 parameters presented can conclusion the graph about the fouling. The location of the deposit growth and the quality can be determined. We could already make 8 tests in our test system, in which we could estimate the place and the quality of the quantity of the fouling, resulting in this result is in an attenuation of 9.2 dB per gram fouling in the measuring cell. We also had some measurements without fouling. It's the type of the chemical system, so sometimes we don't get enough fouling in the measuring cell and in the reactor, so we don't measure the result, and we see that they are not fouling in the measuring cell. So it works very well, and we always can see this growth of fouling. This brings me to the end of my presentation. I would like quick summarize the result again. It was shown that the fouling in a conditioned emulsion polymerization process can be observed and estimated with a developed ultrasonic measurement technique. The system conditions, however, must remain content and not be subjected to large variations. In order to determine the statistic thresholds for initialization cleaning cycles, the thresholds must be determined experimentally. Further measurements are planned for the future to actualize characterization from the fouling and the materials, to better characterization of the materials and fouling. Thank you very much for your attention, and now I'm open for questions.